Let's resume this bad boy. Today is the 24th, and we are going to do, how do we say this? Like writing, what do we want to call them? Like features, I guess. Writing features of an ellipse when given the equation. So it's kind of backwardsy of what maybe we came from at the very first. Like rather than, we have to kind of eyeball looking at a graph, perhaps A, B, C, all these different things. And then we go from there and we write the equation. Today, we get the equation first, and then we have to go backwards and just list out all like just a laundry list of do this, 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 this. I don't think you guys are going to struggle. This year has been really crazy cool in that people just seem to be learning things well. Which I know sounds like isn't that what it's supposed to be, but not every year feels that way. So this year, let's just hope this good fortune continues. So here's an ellipse: x plus 9 squared over 4 plus y minus 4 squared over 100 equals 1. So you recognize that by now that that's the equation of an elongated circle, right? An eccentric circle, an ellipse. So just talk to me real quick about some stuff. And you okay, bud? Yeah. So talk to me about it. Just let's kind of maybe touch base and see where we are with our understanding. Give me anything you know about the
We
ellipse.
can deduce the center from it,
The center is what?
negative 9, 4.
Absolutely. I mean, I feel like that's worth writing down. That's usually going to be at the top of my list. So when I give you the quiz or whatever, they're going to be, or the assignment, we'll see how much time we have today. There's going to be 7 things I want you to list, and the first one is just going to be the center. So let's write that down. So the center is that, what did you say, Zach?
Negative 9 and 4.
Good job. Right. And maybe we'll graph these at some point. This assignment does not have any graphing on it. I didn't put that there. I didn't want to deal with that right now. But like maybe we'll do this assignment with just the skills, and then maybe the follow-up assignment 36 could be same stuff, but let's now sketch a graph and try to and then laugh at ourselves as our ellipses look like elongated lemons that got punched and stuff like that. They're really like parabolas are hard to draw, ellipses are even harder. So anyways, let's get through this. So the center is at negative 9, 4. The next thing that I want is the length of the major axis. And eventually we'll have to, I thought about abbreviating it as length of MA, but the trouble is we also have to do the minor axis. So we'll come up with something. We don't want to write. Yeah, we'll figure something out as we go, like, but we don't want to write this out every time. But for the first time, let's write it out so that we know if we look back, if you're the kind of person that looks back at your notes, then you'll know what this means. Can you tell me just from looking at this what the length of the major axis is?
20.
You guys are pretty remarkable. Yeah, and again, that's I just never know how a question like that is going to go. And you guys are pretty bright. So you deduced from the equation that A is 10, right? And then you doubled that because you know that the minor, the major axis is just, you guys are amazing. So the length of the major axis is 20 units. Great job. Okay, let me zoom out a little bit so I can fit a little bit more on my, oh, I like that. But can you see that?
Yeah.
You can read that okay, good. The next thing is the length of the minor axis. And so, and again, I realize this is going to be light work for a bright group like yourself, but let's get her done officially. The length of the minor axis is what? 4. Again, you just square root the 4, get 2, double that, you get back your 4, oddly enough. Okay. Next up, we have the vertices. I think these next ones are where it gets a little bit tougher. So the first 3 are pretty easy. Last 4, a little harder, maybe. You're going to find yourself doing a lot of things with your hands, and eventually you'll notice I left you a lot of room on the paper. That's because you're going to probably want to have a little sandbox experience here. And so the way I look at this is I want to get a visual on how this is oriented. And again, not everybody needs the visual. I've said that many times before, but I can't say enough like how helpful it can be. So it doesn't have to be perfect, but let's just make a quick sketch. It doesn't, again, we're not going for artistry here. All right. So the first thing we'd want to do is obviously sketch the center, and that's at -9, 4, which might be, I don't know, right about like here. Are we agreeable to those terms?
Yeah.
What's the orientation of this ellipse? It's a
It's
tall.
tall.
Yeah, we know that because the bigger number, the a squared, is under the y, right? And so we know that our vertices are going to be above and below the center, correct? Not to the side. And how far up am I going to go to find a vertex?
10.
Right. So I'm going to go up 10 units, which in fact does take me up to a y value of 14.
The covertices are from B.
We okay? So if we understand visually what's going on, we understand that there has to be a vertex up here
At -9.
and a vertex down here.
Negative.
And again, some people do this without pictures, and if you're not there today, you'll probably just all of you eventually, I'm guessing, get there. But like, I like to see stuff. So knowing that it's a tall ellipse, knowing that A is 10, I can say I have to go up 10 units from the center to get to a top vertex. And so the vertices are at these 2 points, the high point and the low point. What's the name of this toppy point? Good job. And what are the coordinates of the bottom vertex?
-9, -6.
-9, -6. Good job. Still good? Okay. The next thing you know this is the covertices. And the covertices are going to be pretty close by. And like Anderson spotted it pretty quick. This is a pretty long, skinny sort of ellipse. And you know that because you could see the ratio of A to B just from those two numbers. And so what's my B value?
Their B was 2.
My B is 2. So that means that my covertices, they're not very far away. Like they're snuggled up, they're pretty tight. And I don't even think that that's scaled correctly, but that's kind of the idea. So knowing that my B value is 2, I know that I have to go to the right 2 or to the left 2. I mean, I got to do them both eventually. Let's write this one down. Where are my co-vertices?
So good. Which one? 11 toward the
I love that. The -11, 4 is solid. That means that we had to go 2 places to the left from the center, which puts us at -11. And then going 2 places to the right puts us at -7. The y does not change with the covertices in this case. So once you know what kind of an ellipse you have, your x's will change with the vertices and your y's will change with the covertices, vice versa, depending on which one it is. So the other one you said was -7, 4. Nice. The next thing is the focal length. And there's a reason that we're going to do this in this order. I'm not going to ask you for the foci yet because we need the focal length to find the foci. So the foci is generally going to be the hardest, but again, as you guys are proving today, nothing's going to be much of a challenge probably for you. But I do want to find the focal length. And remember, focal length has another name. What do we call him? His name is C. And so this is where we're going to want to bust out our happy little formula, which we remember we have 3 modified versions of the formula. The big daddy formula is, let me just make a new page, is I believe that A squared is equal to B squared. No, did I say that wrong?
A squared is equal to C squared plus 2.
C squared plus B squared. Okay. And so then if I want to find C, I don't ever have the modified ones written down. I'm sure you guys have them, but I just need to see this one and then I'm good to go. So C obviously will equal the square root of A squared minus B squared, right? And what's A? 100. And what's B? Yeah, I mean, yeah, 2, but 4. And 100 minus 4 is
96.
96. So our focal length is the square root of 96, which is exactly 4 root 6. I felt a little pause there. I just need to kind of read the room here. Is everybody okay with that?
Yeah.
Okay.
Do you want us to do it like that and no decimals?
Yes,
Okay.
we're going to leave the decimals out. And if there was, like when we go to graph, it would be good to do a decimal. Like you should always have the exact version. I speak for geometry teachers, trigonometry teachers. Everyone wants the exact. And then maybe on top of that, it's a good idea to write the ruined decimal one, like for practical purposes. But we should always start with the exact. So since we don't have to graph, this is the only one we're going to do. So the focal length is 4√6. Are we okay with that? Okay. So going back to my other page, then I can say the focal length is equal to 4√6. This is an upper level math class, but I still would be remiss if I didn't ask. Do you have any questions how I got 4√6? Breaking down the square root of 96. Be good. Okay. So that the reason we do the focal length first is because now that's what's going to enable us to find the foci. And what we know about the foci is they're out here somewhere. They're up here and down here. And what we want to do is just put a name with the face. I kind of know ballpark where they're going to be, but some bossy math teacher is asking me to actually name them, right? So I feel like I should have had 7 things. What did I miss? Length of the center, length of major, length of minor, vertices, co-vertices, focal. Oh, and the foci. Of course, I just didn't write it down yet. My bad. So we need to complete this problem, we need to say that the foci are at, and here we go. Which coordinate in this case, as I travel from my center up to the north focus and down to the south focus, which coordinate is going to change?
The Y.
The y is going to change. When you move up and down on a graph, your x does not change, right? So I may not know like right now immediately what my foci are, but I do know this much. My foci both have x coordinates of -9. We agree? Good. Now let's just think simply about this and don't try to make math out of this, okay? You know stuff about like terms, unlike terms. What's going to be the y coordinate of my northern focus? It is 4 plus 4√6. Nice job. And again, does that equal something like, yes. And if I'm going to make a graph, knowing that 13 point whatever you were about to say, that would be useful if I were going to make a graph. But again, we should always pocket the exact answers and then we can do whatever we wish after that. Okay. And then the same logic applies to the south focus. Again, the x stays the same. It's going to be my old y coordinate 4 minus the focal length 4√6.
Okay.
Got it? That's not a very heavy lift, is it? You guys have done a lot of good work before this that makes this feel like not a heavy lift. We're going to do one more real quick together. Obviously, I want to do one that's oriented the other way, an X strong ellipse, and then we'll probably let you get started today, unless you don't want to, but we'll see how it goes. Any questions about that?
Yeah. Good.
Okay. And could we graph this?
Yeah.
Yeah. Like if I gave you a big grid, you could graph it. You could put your little points on there, and we'll save that for probably Thursday, if you don't mind. All right, let's go again. Round number 2. We are going to do x minus 5 squared over 81 plus y minus 9 squared over the 16 equals the 1. So let's knock these out. Bless you. Let's knock them out in the exact same order as we knocked out the other guy. Who's first? Senta. Yes. So we want to say center at 5, 9. Next up is length of MA, I guess.
18.
Oh, and that's 18 is good. And then let's call the other one like MIA. minor axis. That's really a lame abbreviation, by the way. What would be the length of the minor axis? 8 is perfect. 8, as my wife would say, 8 is great. Um, Next up is where are the vertices? So now is when we have to just lock in on some very basic knowledge. Which way does this parabola orient itself?
Wide.
He's wide. We know because power numbers under the x. An x strong parabola is a sideways strong parabola. And so how far away am I going to have to go from the center to get to one of the vertices?
9.
I have to go 9 units, half the major axis, right? And so and I'm just trying to see how far we can go, but if I don't draw a picture, just kind of a challenge for all of us here. If you've already drawn the picture, more power, like good on you. Just kind of seeing how far we can go. So if we go from the center to our vertices, which are out here, who's changing? X's and Y is leveled and staying the same, right?
Mhm.
And you said we're going out 9.
Yeah, so it should be T.
So my vertex on the right would be 14, 9. And my vertex on the left would be what? -4, 9. Noise. Let's find our co-vertices. So we reset back to 5, 9, and we understand that the co-vertices are going to be to the north and the south this time. And how far up or down do we have to go?
4.
4, half the minor axis, right? And so if I go up 4, the y coordinate changes. What do I get?
5.
5, 5 is the low one.
Yeah.
And 5, 13 is the upper one. And once we survive that, now it's just all about C. All right, we need C, and then we need to use C to modify one of the coordinates to find the foci. So again, I don't think there's a lot going on. So what is our formula for C?
A squared.
Yeah, it's the square root of a squared minus b squared, right? And a squared is 81, I believe.
Yeah.
And b squared is 16. And 81 minus 16 is
60.
65. So we can say that the focal length is the square root of 65, which when the time comes to graph, we would say that's 8, basically. Like on a piece of graph paper, you'd have to go a tiny little bit past 8, which is almost imperceptible at that point. So for practical purposes, 8-ish, right? You'd still use your squiggly equal sign to say like this isn't perfect, but close enough. So when we go to find our foci, which coordinate's going to change? The X is, right? Because it's a long sideways ellipse, right? So the foci are out to the east and the west. And so knowing your vertices, not your vertices, but your center, I think the key here is reset to this red box. Go back to here. He's your focus. Just say, okay, I'm going to modify my X coordinates. I'm going to go to the right this far. I'm going to go to the left this far. So where are my foci?
5 plus this 65.
So when I go to the right, I'm at 5 plus root 65, comma 9. And what's my other focus? Right. And why are we leaving root 65 as root 65? Because it doesn't break down. The only factors of 65 would have been, of course, root 5 and root 13, and those are both trash, right? So I don't sense any issues. Are we okay?
Yeah.
Okay. Let's get started on this today, and then tomorrow when I'm gone, I'll give you another assignment like this, and I'll add some graphies where you can sketch a graph. Sound good? Yeah, tomorrow I'm gone for state math. Yes.
Andy, Jim. What? Jim. I like.